the quadratic equation we're going to get is 4.5 minus 2 is 2.5. Then I'm going to do this minus this, 38.33 minus 117.33, negative 79. Then I'm going to do this minus this. Two 2.5 t squared equals minus 790 minus this equals 0. So that's the final quadratic equation I end up with. Any questions on that so far? No? And then you solve that for t. .635 seconds. 35.635. So, how many seconds is it going to take the police to catch up to the speeding car overall? If I ask how many overall, well, then add 3 seconds to that. That's your overall time. So that's the answer, 38.635. T total. So add 3 seconds to that, because that T is the time elapsed after the original 3 seconds. So that's going to be a chase that lasts about a minute. Okay, now, how far down will the police catch up? In other words, if I want to know how long it takes before he catches up, well, I can simply take the t, this t, and put it back into this equation and solve for x of the police, right? So 58.66 plus 33.83 plus 38.33 times 35.635 plus 4.5, that's going to be pretty large, times t squared, 35.635 squared. 7,172 feet is the total distance of the police from the original time that he saw the car. So the distance is going to be 7,172.72 feet, which is about it's probably about 1.2 miles or something. Something like that, roughly. 5,280, maybe about 1.3, 1.4 miles, something like that. So that's the distance that the police will go before they catch up. And then what will the speed of the police be? The final of the police is going to be, then we can use this equation. Their original speed is 38.33 plus its acceleration is 9 times the t, which is 35.635. Notice the t that I'm using here is not the 38, because the 38 includes the original 3 seconds. So that's the final speed of the police. Okay, so that's pretty fast. If you change that to miles per hour, divide it by 5280, multiply it by 3600, 244 miles an hour is how fast the police gonna go. Oh, okay. Can they go that fast? No? That's too fast, huh? So the realistic version of this problem, which would make it even harder, would be to say, assume the police's maximum speed is 180, and assume the speeding car's maximum speed is 130, then how far does it take to catch up? Then you bring an extra limitation on the problem. They both have fast speed, so they're going to accelerate, then that's it, they can't go any faster. So you bring that the realistic problem becomes a little tougher. So to calculate all that, that would be a little bit harder. But if we assume that they just keep on accelerating, that would be their final speed. Now the speed of the speeding car should be less. Otherwise, the police wouldn't catch up to it. So if you find the speed of the speeding car, that's going to be its original speed is 117.33 plus A is 4 times the T 35.635 So the speeding car is going 259.87 feet per second, which is 177 miles per hour. So that's a little more doable. Okay. So the speeding car is going 177 miles per hour. The police is going at 244. Oh, wait, I wrote wrong here, sorry. This is 177 mile per hour. So the relative velocity between them, the difference is what? About 70. So the delta V is about 70 miles per hour. So when the police catches up to the speeding car, it's going 70 miles an hour faster. So if it bumps the speeding car, that's quite a bump, huh? They hit each other with a relative velocity of 70 miles an hour. It's going to do some damage to that car. Okay? So that became a good problem. Okay? So as you can see, with this problem or any other kind of problem like this, where you have several stages, it's good to draw pictures, break them up into stages, and then apply your equations of linear kinematics to each stage. Like in the beginning stage, neither of them were accelerating. Second stage, the police was accelerating, and then after that, they both were accelerating. So when I got to the stage where they're both accelerating, I can apply the same equation for both and then solve for the t, right? Good, so practice those. There's so many variety of problems that there's just not enough time for me to show you all the different kinds that you can get. But practice the ones that I've got in the review sheet, practice the ones that you have in the homework. Practice, practice, practice. Practice makes perfect.